How to construct the Great Unification Theory, attempts made by scientists. 2. Einstein is a legendary figure in the history of science, and his theories of special relativity and general relativity are well known to the world. Today, let's have a deeper understanding of the formation process of these two theories. In March 1905, Einstein published quantum theory and proposed the photon hypothesis, which believed that light, like atomic electrons, also had particle properties, successfully solving the problem of photoelectric effects. In May of the same year, Einstein published a paper titled On the Electrodynamics of Moving Bodies, using Maxwell's field equations to derive the principle of invariance of the speed of light, i.e. the speed of light is absolute and remains constant in any reference frame or relative motion, and based on the principle of special relativity, i.e. physical laws are equivalent in all inertial frames, he derived the theory of special relativity. In the classical physics founded by Galileo and Newton in the past, time was absolute and unaffected by the relative motion of the observer. But in Einstein's special theory of relativity, since the constant speed of light does not require any reference frame, it is necessary to redefine the transformation of the spacetime reference frame, which is the basic equation in special relativity, the Lorentz transformation. The Lorentz transform assumes two different inertial reference frames, one of which moves at a uniform speed. The famous time dilation effect can be obtained through the Lorentz transformation. Unlike the conservation of mass and energy principles believed in classical Newtonian physics in the past, special relativity holds that mass comes from energy and can be transformed into one another, resulting in an important formula, Einstein's mass-energy formula, E equals mc superscript 2. Special relativity unifies time and space, as well as mass and energy. After proposing the theory of special relativity, Einstein realized that it was incomplete in at least two senses. Firstly, it is stipulated that the propagation speed of any physical interaction cannot exceed the speed of light, which conflicts with Newton's theory of gravity. Secondly, special relativity only applies to uniform motion. Therefore, in 1915, Einstein proposed the theory of general relativity, attempting to extend it to accelerated motion. General relativity holds that the laws of nature and gravity, in the framework of acceleration, are the same, which is the principle of equivalence. According to the principle of equivalence, the speed of light is affected by gravity, and the gravitational field distorts the path of light. But according to Fermat's principle of shortest time, light will take the shortest path between 2 points to move forward. The two seemed contradictory, so Einstein came to a shocking conclusion: if we can observe light rays moving in curves, it means that space itself is curved. The existence of mass energy causes the curvature of the surrounding spacetime. General relativity has pushed relativity to a new height, linking gravity and spacetime together, proposing the famous theory of curvature gravity, explaining gravitational phenomena such as planetary motion and black holes in the solar system, and predicting the existence of gravitational waves. After special and general relativity, Einstein devoted his entire life to studying unified field theory and seeking the principles of all things. Unfortunately, he ultimately failed and left this grand ideal and goal to future generations. Next time, we will share with you the quantum mechanics theory that integrates three natural forces.